So what's new and exciting in Toronto, my friend?
The sun is shining. I think that's that's the biggest excitement. And
Oh yeah, it's 16, 17 degrees lately every day. It's perfect with me.
yeah, me too. It's,
Oh, discussion. I see one question here. Oh,
so we've just opened up the room, so we're getting some folks populating in.
let me just.
Yep, that's just me, webinar host, sending a little message welcoming the attendees. As Mr. Elliott mentioned, we do have the doors open. Welcome, everybody. We'll be starting in a couple of minutes for you here, so just get settled and get comfortable. Make sure your audio is sounding good. And we'll leave it with the Sika team shortly.
Should I leave my camera on, Kamal, or?
Oh, it's up to you. I have a couple of props I might want to show, so I might just leave it on. So those are just coming in. We're just waiting for the room to populate a little more before we get started. Okay, let's give it another minute or so while we get everyone in, and then we'll get going. All right, everyone, I think I'll start getting the ball rolling here. Welcome to our Sika seminar on parking deck membrane systems. My name is Kamal Elliott. I'm the Director of Business Development at Sika in the Commercial Construction Division. Part of my responsibility is involved with our park deck membrane and waterproofing product portfolio, taking them into the future, as it were. Along with me today is my colleague, Michelle Ross. Michelle is the technical representative for Sika Canada in the Ottawa National Capital Region. And Michelle will also be manning the Q&A line. So if you have any questions during the presentation, you're welcome to share them in the Q&A. I think that's the best place. We'll be monitoring that as opposed to the chat line. So Q&A for questions, and then Michelle will answer in real time. As far as I think the setup here, everybody's going to be muted. And I'll run through the program. It's roughly between 60 and 80 minutes of content. There really won't be a Q&A at the end. So if you do have questions, please feel free to ask them during the seminar. So with that, I'll get going. So today our topic again is the Sika Elastic Park Deck waterproofing systems. The intent here today is to cover a number of different things. I think if you're a newcomer to parking structure and parking structure construction and rehabilitation, you'll find some interesting things. If you're an expert, hopefully you'll find some new things as well. As we share with you some basics and best practice, some overview of Sika products, but also some introduction of some newer innovations and technologies that you may not have seen yet. And then we'll round it out toward the end with an introduction of some injection products that can help with leaks in underground garages. I'll mix in some basic information, pictures, some video, cover some best practice, try to help any of those that are in the design and specification get some tips on how to make the selections of products. And I'll also include some case histories that will help you see the products in action. So with that, I'll kick it off. Just a quick at a glance with respect to Sika. Sika established over 100 years ago, a global company based and headquartered in Switzerland, with a footprint that puts us into about 100 plus countries globally. Nice thing about that for us here in Canada is we're able to connect to technology all around the world and bring that technology to the Canadian market. But what really gets us excited at Sika Canada is our presence here in Canada with over 400 strong, with manufacturing facilities, sales and technical people, R&D throughout the country there to partner locally with the Canadian market. Sika has been expanding lately over the last few years. We now have 8 specific business units within Sika operating in various aspects of construction, from underground structures all the way up through to the roof and all parts in between. You'll find a Sika division focused on helping you find solutions for your construction challenges. Michelle and I, my colleague, are focused in the commercial construction group, where we focus specifically on the items you see there. Today, again, we'll be talking about waterproofing and refurbishment of parking structures using protective coatings. All right, so with that, we'll focus in on that. I think, again, when we think about Sika, many of you may have an impression on what we do. Most are familiar with us from a concrete and refurbishment of concrete standpoint. Today, again, we're going to focus in on park deck membranes and injection resins. So we really begin that with a discussion of what is the main function of a park deck membrane. We use the short form in Sika language, PDM. So when I say PDM, I'm referring to park deck membranes. The ultimate objective, typically, when you're selecting this type of product, is that you want to keep water and chlorides out of the reinforcing steel that's in the concrete. If those enter and ingress, the electrochemical process of corrosion kicks in, and that spells trouble for steel reinforced concrete. So we're using park deck membranes to keep liquids and specifically salt out of our structures. And in order to do that, we need to function, and our systems need to function essentially as a waterproofing membrane. And that membrane needs to be able to handle the movement. It needs to be able to bridge cracks and prevent salt and water from getting into the concrete cover and eventually down to the steel. It needs to do that in the presence of potential movement of the structure, obviously the traffic that's going through the structure. All of these things are factors that will affect the performance of our membrane. Wear and tear is certainly something that's well known. Traffic is going to impart wear and tear on the structure, particularly with turning of wheels. In some applications where you're dealing with snow removal, we may get snow plows But that traffic is going to wreak havoc on the membrane if it's not protected properly. This video clip, and I hope the streaming is good enough for you can see them, at least sense the movement. This is just an example of the effect of a turning tire on a substrate or on a deck membrane system. This is actually a clip from our R&D labs in Montreal. This is a Sika test protocol that we established in Germany about 10 years ago to study flooring and parking systems. We're hoping to establish this as a standard in the European market and then eventually in North America as a way to help evaluate the performance when it comes to wear and tear on parking structure or parking deck membranes. So another function of the deck membrane beyond just the waterproofing and the protection is also a safety factor. A couple of things related to slip resistance and friction. We've got cars in motion. We've got people, pedestrians walking. We can also utilize the color and that effect to provide a safety element as well, using clear demarcations of direction and traffic wayfinding and as well pedestrian aisles. Kind of building on that theme of safety, we can look at these products from a security standpoint. You see the picture on the top. On the left, the dark, drab, dreary environment may not feel safe. And on the right, you can see the effect and the light reflectiveness of using coatings as well as the park deck finish to provide a feeling of security. And then further on, as we go down, we see the use of aesthetics and color. Not so much in North America, but we see in other parts of the world, color is really used effectively in parking structures to bring a new dimension, depending on whether it's a commercial or residential environment. The owner of the structure may have desires to improve that user experience or enhance that user experience. And you can see some examples here where we're utilizing color to do that. Throughout the presentation, I'll reference a few things back to the standards. So in Canada, we have CSA S413, which is our standard for building parking structures. And in there, there's reference to the use of park deck membranes. Also within that, we have reference to a specification called ASTM C957, which essentially breaks down some specific product properties and performance characteristics that you need to function in this type of environment. So that's another good reference point that specifiers can use. And inside there, you'll see some standard practices as it relates to details and treatment of cracks and joints and various other aspects of the products that we'll talk about. Okay, so this is essentially what I would consider the universal system build of a park deck membrane. You're going to see this similarly amongst various manufacturers of the product here in North America. This is synonymous with what we call our Sika 3900 system. It's essentially building up from concrete, priming, applying a membrane, and protecting that membrane with wear courses and top coats. So we'll basically, through the next section here, kind of walk through how we build that system and the key considerations as we go through. Just quickly, just an overview. Sika offers a number of options throughout the buildup of a park deck membrane system. And here's, you see just a kind of a quick overview of a number of options. And I think it's important to reference that we do have multiple ways to approach based on various conditions that we're going to encounter. And you'll see different products from Sika that will help you through those challenges. All right, so we begin the discussion with the substrate. I think this is the logical place to start when we were looking at trying to bond a system like this effectively to concrete. We have to first look at the concrete. The first aspect that we would introduce is making sure that we have sufficient surface preparation. I think when most know when you build or construct or cast concrete, that top surface layer of the concrete, we call it the latence layer. It's got a very high water cement ratio, and it's typically the weakest point in the concrete. And we really don't want to build our system with that as our foundation. So typically we want to remove that. We want to open up We want to remove that latence layer, open up that concrete so that we can bite into it essentially. This picture on the left shows a shot blast, steel shot blast machine. It's an effective method in terms of getting that profile and doing any removal of latents. Also surface contamination. And then on the right, you see an example of some surface profile pads, which are established by the International Concrete Repair Institute, giving us a sense of different textures. And we like to get our deck membranes onto a surface that's in the 3 to 4, CSP 3 to 4 range. We find that's the optimal surface texture. It's not too porous, and it's certainly coarse enough for us to bite into. The other aspect of the concrete is the strength. On the left, we show an example of a pull-off test where we're testing the tensile properties of the concrete. If concrete during construction was rain damaged, it would produce something that really wouldn't be sufficient for us to bond our system to. So we always want to make sure in our assessment of the concrete before we apply a coating that the concrete itself has a sufficient strength. On the right, we show the bonding of the coating system to that concrete. And ideally, you see in the failure modes, if you can look closer there on the bottom right, you see a concrete failure mode. That's ideally what we're looking for with our deck membranes and our coating systems. We want the bond strength of the system to the concrete to actually exceed the tensile strength of the concrete. So if we were to pull it all off, we want the concrete to be the weakest link in that scenario. And you can see here a reference to the CSAS 413. They recommend a 1.4 MPa minimum tensile strength and bond strength to the concrete. The other aspect of concrete is moisture. Moisture is not good for bonding coatings, so we want to make sure our environment and our substrate is as dry as possible, ideally below 4%. And you see an example here of something called a Tramex moisture meter, which measures the moisture content by weight in the concrete. We want to keep that below 4% ideally, but if the moisture is higher in concrete, we do have a number of ways we can treat the surface and deal with elevated levels of moisture. But it's always important that you understand your moisture status before you move forward with the installation. The other aspect of moisture is the dew point. So at some point, certain temperatures and relative humidity, condensation dew will form on the surface of concrete. We do not want to coat over that. So that's a calculation that's made based on the actual temperature and relative humidity at the surface. And our advisement is that we stay 3 degrees C above that dew point temperature to ensure that we don't run into problems with moisture. And these are good practices for contractors to keep logs, keep records of these readings when they're doing the installation, to ensure that they're not going into conditions that could lead to failure, as well as keep a record in case they need to do troubleshooting down the road if something did go sideways with the installation. So one of the good practices that can be implemented in the specification, you'll see it in our data sheets as well, where we recommend both of these aspects to be covered as far as moisture goes. Okay, the next aspect with the concrete is the surface treatment, or the crack treatment rather, and making sure that those cracks, which can serve as a direct route for water and chlorides down to the steel, we got to make sure that we deal with them. We have to make sure that we treat them accordingly. The membrane sometimes isn't enough to deal with those cracks, and we have to open them up and we have to put a sealant in there, something that's flexible, that's going to make that crack watertight, and then we'll deal with the buildup of the system over that. Not to go into too much detail here, but these are just a few examples of some crack details. These are somewhat universal. You'll see this stuff called out again in the S413 standards. Most manufacturers will offer you similar detail drawings with their product systems, showing you how to deal with cracks. Depending on the thickness of the crack and the movement characteristics of the crack, there's a number of different ways you can detail. And there's other details as well with respect to terminations and penetrations through your deck and how to treat those with the membrane system most effectively. And this is just a further side note. Sika also has a division called M-Seal, where we use mechanical seals to seal high movement joints. And it's important to know how to tie those together with the parking deck membrane so you get a continuous or continuity of seal in your structure. And with Sika and MCO, we have evaluated the various products that have to touch each other and done some testing, and we can provide some good practice to guide you going forward when these products come together on a job site. All right, so that's it for the concrete. We've got it prepped. We've dealt with the concerns around the concrete condition, and now we're going to start building our system up. And we begin with priming. So I love this image because I think it really gives a good illustration, visualization of the effectiveness of a primer. A primer is an essential, we believe is an essential step in ensuring your system is really anchored in to the concrete and you've got a good foundation to build up from. So penetration, as you can see, we want to dig our primer deep into the concrete to ensure that we're locked in mechanically. But we also want to have some of the priming material at the surface because we want a surface lying effect for our membrane. We don't want our membrane soaking into concrete. We want our membrane, as we'll talk about in a slide later, we want our membrane to be uniform. So surface lying effect is an important aspect of the priming step. And then we also want to deal with something called outgassing. And outgassing, you can imagine you're shot blasting concrete, you're opening up the surface, and that concrete's going to want to exhale. But you're now putting chemicals in, you're putting coatings in, and you're displacing air. So that air has got to go somewhere, and it's going to come up and diffuse its way up through your membrane. If you have a primer, you can lock out that air, you can lock out that outgassing, and you can spare your membrane from experiencing something like this. And I throw in the picture of the aero bar because that's what you don't want your membrane to look like. And that's what priming really helps you effectively control and offset. So real important aspect of priming is to make sure you get that outgassing dealt with in the priming coat rather than in the membrane. Sika, we offer a number of primers. I mentioned earlier, we have some moisture tolerant primers. We have some fast primers that we're introducing soon to the market. And then if you're looking at a situation where maybe you're not removing the entire existing deck membrane, perhaps it's in good shape, you just want to freshen up the top coat, reestablish the wear layer, then we offer a recoat primer because polyurethanes typically don't like to be recoated. A recoat primer can help improve adhesion and give you a better base to build up your recoat from. So a few options as it relates to priming. One tip I think is important to consider if you're specifying deck membrane systems, you'll see primed systems on the market. You'll also see unprimed systems on the market or primerless systems on the market. And I think when you're specifying, you need to think in terms of apples to apples because I really don't believe that you're getting the same performance or the same value from an unprimed system. You may look at unprimed systems maybe for shorter term objectives, but if you're looking for long-term durability and life expectancy of a membrane system, the prime systems tend to be the longer performing systems. And here's just a quick clip showing, this is our MT primer. It's slightly tinted red, so you can see it going down. And you can see how it's being pushed by a squeegee and it's soaking into the properly prepped surface. You can see that on the right, and that primer is able to penetrate down in. So it's a pretty straightforward installation, flat squeegee usually, followed by a back roll that's going to give uniform, even distribution of the liquid material. All right, now we get into the waterproofing layer, which is the real function of these systems in essence, and that's our elastomeric membrane. You know, again, primary function here now is to serve as waterproofing, is to bridge the cracks, keep that water and chlorides out of the steel reinforced concrete. But you need to do that again in the presence of a number of mitigating factors. You've got cracks that are going to open and close based on temperature, sometimes based on live load. And you need to be able to do that in a varying degree of climates or temperatures. So, you know, you're going to need to do that in the summer as well as in the winter. So this is a reference here to an ASTM test that comes under the C957 called low temperature crack bridging, where we cycle the membrane material through opening and closing at very low temperatures, -26°C, to ensure that the properties of the product are going to be intact even in cold temperatures. And obviously that's important for us here in Canada. Also important that the thickness of the membrane is uniform. So when they're applying it, they can't apply it in 5 mils over here and 40 mils over here. It really needs to be uniform to optimize the elastic properties of the material. We at Sika tint our membrane, our 390 membrane green. It's a translucent tint. So it tells us that membrane is going down, and if it's not applied thick enough, you can see through it. You can see the concrete through it. And also in the future, if you're several years down the road and your system is wearing and you start to see green, that's a signal indicator that you need to reestablish your wearing layer or your top coat before you compromise your membrane. So membrane is very critical. It's important that it goes down properly and at the proper thickness and given its best chance to function. And here you see it quickly. This is being installed with a V-notch squeegee to make sure they get the adequate thickness. And then it's also being back rolled. And what most contractors will do, they will also calculate by volume into a specific area. So they know by volume, the math is straightforward, how much material you need to achieve 25 or 30 mils, and they'll make sure the material goes in to that specific area. And often they'll grid out the area and make sure that each unit goes in to that area specifically. So something that's also easy to monitor with wet film thickness gauges to ensure that you're not light or heavy in certain areas. You can do quality assurance on the job to make sure that the membrane is going in uniform. All right, so we've got the concrete, we've got the primer, we've got the membrane in place. Now we need to protect that membrane. And protection of a membrane can really vary, and it varies depending on the type of zone, the type of traffic that you're expecting to expose that membrane to. So that's really going to vary. We've kind of come to a consensus in the industry that we have 3 primary zones where we can modify the thickness of the top coat rather, based on these zones. And you can look at light, medium, and heavy duty as kind of the best ways to characterize. And you can see here we've sort of typified light as meaning pedestrian or parking stall, medium being the drive lane, and then heavy being a lot of other areas where you're either turning or you're stopping on ramps, you're getting a lot of traffic, or maybe you're on an exposed top deck, and these would be considered heavy areas. And again, that's going to vary depending on what kind of traffic usage you're expecting on the job. So this can be modified. This is really saying the same thing again, really just kind of showing you visually. You're going to have those parking stalls where it's very slow, cars moving in and out. You're going to have the drive lanes, and then you're going to have the turn lanes, which are going to be more intense, as well as the ramp and the entrance and exit areas. So what's nice about this is you're not necessarily, and this proportionally may not be true in this image, but typically you're going to see 60% of a parking garage is going to be light duty. So you don't have to throw all the beefy thickness into the entire parking garage. You can lighten up in the majority of the area and then build up accordingly in the heavy duty hot zones. At most manufacturers, you'll see again something similar where they'll kind of give you a range of thicknesses depending on zone and using the specific products and how many mils of thickness that they recommend you go with. So from a Sika standpoint, just a few examples of some of our workhorse top coat materials and where they fit. Our workhorse is essentially what we call our Sika Elastic 391N. This is a material that can be used in light, medium, and heavy duty applications. Again, thickness will vary depending on the zone. It's a nice versatile product. Contractor doesn't need to have 2 or 3 different top coats to deal with the various areas. You can utilize that primary 391N to do the majority of the traffic conditions that he's going to encounter in a typical application. If he's getting into exterior or UV exposed applications where the 391N would typically, gray would start to turn green if exposed to sunlight, then we offer a what we call an aliphatic polyurethane, which is UV stable. So gray will stay gray. And this is what we would use in these exposed to sunlight type scenarios. So similar properties to the 391N, except it's also got that UV stability. And the third product I show here is what we call our 220FS. It's a newer product in our offering. And what it does, first benefit is it provides a faster cure. The FS is fast set. So where the 394 and the 391 may require about 7-8 hours between recoat and upwards of 24 to 48 hours before you really truly open the parking structure to full traffic, the 220FS can get you there quite a bit faster. So 3 hours in recoat and 8 to 10 hours, you could start opening it up to light traffic. So some nice advantages there from a time perspective. And then in terms of the material itself, we can tint that to pretty much any color in the rainbow. So if you're looking in typical sense, if you come to a manufacturer and you say, I want 5 gallons or 5 units of a special green for e-vehicle areas, they may look at you funny and ask you for, a minimum of 200 gallons because they're making that material in a batch configuration in the plant. With the 220FS, we're now making it in 5-gallon or 20-liter units, and we can oblige that special color or small quantity in order to give you color and start to expand the use of color in these facilities. So a couple of nice advantages with the 220FS. So here's just a video clip showing a top coat going down, not showing the sand going in, but typically you'll also have sand being broadcasted in. But you see one fellow here not squeegeeing and the other fellow is back rolling in order to make sure the uniform dispersion or the uniform spreading of the material takes place. So pretty straightforward. Again, the broadcasting would be another part of this. That would either be a full broadcast or a partial broadcast where we back roll and encapsulate the aggregate to give us a texture. A couple of quick pictures around the country here. This is a typical application, underground parking garage in a condominium building. This particular picture is 5 years old, or the installation is 5 years old. And you can see it's maintained pretty good performance over this 5-year period and functioning quite well. But this is typical of what we see in parking garages around the country. This is a special application using the 220FS. This was previously others, I guess, supplied the membrane years ago, and you can see some wearing and tearing at the bottom of the ramp there behind the guy in the middle. They wanted to get that ramp redone, and they wanted it done relatively quickly. So they used the 220FS as their top coat in order to get that garage. This is a hotel in Whistler, BC. That can see some good, well, back in the day, pre-COVID, it was seeing a lot of business, and your motivation is to get that ramp shut down for a minimal amount of time and get it back into service. So the FS was utilized for that. This is a really interesting project. This is I would say it's beyond a heavy duty. This is into extra heavy duty. In terms of an application where we've got a really thick buildup of our wear layer. And this client wanted to also have a signal layer in their wear layer. So the intermediate coat was tinted yellow, our 220FS, seeded with aggregate, and then top coated everything with gray. And then during the life of the structure, if they start to wear through that gray layer, they'll immediately see that yellow signal layer, and they'll know it's a signal to start making plans to reestablish their wear layer in a future recoat. So really nice new project just happening literally as we speak in Montreal. So we talked about heavy duty. Then we get into this concept of extra heavy duty. And extra heavy duty can really be treated effectively with some lessons we've learned from the bridge industry, particularly in the US, where they have a lot of exposed concrete decks. And we can apply some of the similar principles on top decks and in parts of garages where you've got heavy traffic ramps and turn lanes, as we mentioned. So here we're utilizing something called a low modulus epoxy. So it's an epoxy that's got some flexibility to it. And into that epoxy, we're broadcasting a very hard aggregate, typically a trap rock aggregate. So this is basalt. It's very hard. It's harder than quartz silica on the Mohs hardness scale. So it's going to stand up to that crushing and the wear and tear that you're going to see potentially on a top deck with snow plows, or again, very, very heavy trafficked areas that need that additional beef to them. So this is something that we can do very effectively on parking structures. It's a pretty quick system, 2 to 3 hours between layers, and then a few hours as we wait for it to cure before we open it up to traffic. So quite a bit of this has been done in the Ottawa area, actually, and I've got a little bit of a case to show at the Saint Laurent Shopping Center with Alti Construction, who's doing quite a bit of the 22 low mod in the area. Here they had a ramp that had a lot of cracking. And we know cracking is not good. We don't want to have water and salt going in. So they dealt with the cracks. And then as an additional measure, they put a membrane down. So we used the 390 elastomeric membrane after treating the cracks. And then we built up a couple of layers of this 22 low mod system. So just to show you how it went through the process, you see on the left, the green membrane has been applied to the treated cracks and surface after priming. You also see it covered. So, you know, they're taking some extra precaution here. They're making sure they're keeping rain and they're keeping maybe sunlight or heat variations off of their deck. They want to keep things as uniform and as consistent as they can when they apply these chemical materials. And then on the right, you're seeing actually the second layer of the 22 low mod going in. You're seeing fellows squeegeeing and back rolling, and then the fellow in the background with the shovel is broadcasting the trap rock aggregate into the wet liquid, and then that all sets. The excess material is removed, swept off, and then what you end up with is a finish that's a very hard, high traction, high friction, durable system. In this case, we've got a waterproof membrane underneath. We're primed, we're bonded well to the concrete, and then we've got this very durable, extra heavy duty wearing surface that's going to stand up to the kind of traffic that you're going to see on a ramp. This ramp's pretty much a straight shot. Some ramps are they have a ticket spitter or a gate halfway through, so cars are stopping and starting on their way up and on their way down, and that really wreaks havoc on these types of systems. So having a heavy duty build up with a hard aggregate really is a good way to go for long-term durability. All right, so that kind of brings us to the end of kind of what we'd call our conventional systems for everything from light duty to heavy and extra heavy duty. And now's the part of the show where I'm going to tell you all the shortcomings of the systems I've talked to you about, because I'm going to segue into a newer technology that is becoming more prevalent in the marketplace that can kind of help pick up on some of the shortcomings of the polyurethanes and the epoxy systems that I've shown you. So, some of you may be familiar with this term PUMA, and I'll explain what that means. It's a technology that was launched in the deck membrane system within the last decade, but the base technology itself has been around for many decades. So I think the case for PUMA begins with just kind of a revisit of the kind of traffic that you're going to see in a parking structure. So we talked about the light duty, the medium duty, and the heavy duty aspects, but we really didn't harp on the uniqueness of that entrance exit area. And that hot zone, that I will call it, in a parking structure is going to see all the cars. So all the cars coming into that structure are going to go through in and out of that hot zone, right? And that hot zone or that entrance area is really the most disruptive area, right? If you want to shut it down and actually refurbish it, right? Because now you're getting into challenges with access in and out of the facility, particularly if there's only one way in and out. So it's very disruptive, and with that comes cost. Just especially if it's a commercial garage where the people are paying to park. Being disruptive in that case is actually money out of the owner's pocket. But the good thing is it's a relatively small area. So, in terms of the overall footprint of a structure, it may be only, 1,000 square feet, as opposed to, the whole 30,000 or 100,000 square foot footprint of a parking garage. This will be a relatively small area. So there's some hope in that. So there is that. So the idea though is, and again, if you've been around parking structures for a while, you've probably got a library similar to this of various failed deck membranes in these entrance areas, in these areas where cars are turning and they're stopping and they're starting and they're ramps and, they're really beating up. So when an owner thinks about, a system cost at the beginning, does he think about the total cost of ownership, the cost of every 2 to 3 years having to fix these areas and shutting down or disrupting his operation in order to do that? And the costs of doing that do add up. Time is money, ultimately, right? So how do we get past these challenges? How do we get around some of the shortcomings of epoxy and polyurethane? A further aspect is temperature. Epoxies, polyurethanes, you get below 10 degrees C, they don't like to cure. They're dependent on that ambient temperature being at 10 degrees in order to get a proper cure and allow that traffic to come back. So when you're dealing with these types of systems, you're working around seasons in some cases, or you're spending money to heat the area, hoard the area and heat the area in order to bring the temperature up so the epoxies and the polyurethanes can cure properly. The timeline for installation from the point at which you start the priming to the point at which you open it up for traffic for most polyurethane and epoxy systems could be 3 to 6 days. Depends on the scope of the work, the size, maybe the temperature, but you're into multiple days when it comes to installing your conventional polyurethane and epoxy systems. So there's a number of technologies out there that manufacturers can choose from in terms of coating systems. There's a few of them shown here. Epoxies, polyurethanes we're familiar with, but there's some other technologies in here that we can utilize some of their properties. And what the industry's done is taken a couple of them and created a hybrid to take the best of both technologies. So the concept of PUMA comes from taking polyurethane, which is synonymous with flexibility and elastomeric properties and bridging cracks, and combining that with MMA or methyl methacrylate technology, which is really synonymous with speed. MMAs are super fast. They're curing in a matter of minutes, hours, versus polyurethane, which is hours, multiple hours, and days. So putting those together, we get polyurethane methyl methacrylate, or the industry term is PUMA. So just again to re-illustrate the fact from a curing standpoint, on the left we're talking minutes. We're typically recoating in 40 to 60 minutes with PUMA and PMMA technologies, whereas we're into multiple hours and even days when it comes to the epoxies and polyurethane. PUMA is an advanced technology over the more conventional PMMA, and where you see its benefit probably most is when you look at the elongation. So typically, historically, you could use a PMMA technology as a membrane and it would have flexible properties, and they were fine at 20 degrees C. But as you got colder, as you can see here, the red line, as you got colder, the material started to lose its elongation properties, right? By incorporating PUMA, you're able to maintain a lot of that elongation elastomeric property, even at cold temperature, which again, important for us here in Canada. We want to utilize products that are going to be elastic and functioning through the full 4 seasons, right? So PUMA has the advantage over PMMA of being more flexible at colder temperatures. PUMA varies a little bit from your typical, again, epoxies and polyurethanes, which are normally A and B mixed at the site in very specific proportions, dependent on heat. With PMMA and PUMA resins, we're actually using something called a methacrylate monomer, and that monomer is initiated, or the polymerization is initiated by the addition of a benzyl peroxide initiator, right? And you see that in the middle picture where we're stirring in that benzyl peroxide initiator, and that's going to trigger our polymerization of our MMA monomer into a polymer. And then what we need in order to determine the dosage of that benzyl peroxide is we need to know the temperature. So the contractor is going to be monitoring temperature, and then he needs to dose it accordingly by weight. So he's going to measure the weight on the job site to ensure that he's got the right amount. So he can really basically modify his dosage based on the temperature that he's dealing with. And typically that's going to be one temperature through the course of a project or a course of a day, but it may vary depending on what the site conditions actually are. So he can modify as he goes. But for the most part, the general requirements for installation of an MMA system are very similar. Most things are similar to that of an epoxy or polyurethane, with the exception of a couple things. We can go colder with the MMA, so you see 0 degrees C, we're a little bit conservative. You can get down to freezing temperatures with these materials, whereas epoxies and polyurethanes, anything below 10 degrees C, and you start to really see the effects of slowing cure, slowing reaction, and borderline into problematic situations. So you're better off in a cooler environment with the MMA. We also have a ventilation requirement. So if your exterior or if your parking garage has open sides, it's generally not an issue. But if you're down below in parking underground, P2, P3, we need to make sure that we're moving air. We don't want to stagnate the cure. The way the curing mechanism works, we need to have fresh air coming in to ensure that the system cures properly and that it doesn't cure preferentially with oxygen that's sitting above it. We also want to move air because there is a nuisance odor. It's not a hazardous odor necessarily in the concentrations that we're going to see, but it doesn't smell like roses. So it's an aside benefit of the fact that you have to move the air for curing purposes, but you can also move it and benefit from the fact that you're not going to have that smell lingering. Smell doesn't linger very long because this material is curing extremely quickly. All right, so that comes to our Sika Elastic Pronto system. So our system for utilizing the Puma technology is our Sika Elastic Pronto. And the way we build it, first benefit really is durability. Because we can go so quickly, we're able to build up a very robust, thick, durable system in a matter of hours. So we can take advantage of that and build a thick buildup that can last you for many years to come, that you're not going to be looking at recoating in 2 to 3 years. So that's first aspect, durability. Second aspect is flexibility. Because of the Puma technology, we're now able to bridge cracks at lower temperatures. And then, of course, that whole rapid curing comes along again. And that plays out in various scenarios in many ways and can really bring some value to the client and some efficiency to the contractor, because it is a single day installation. You're not looking at long multiple days of shutdown and multiple mobilizations back and forth to the job site. So rapid cure really does bring a lot of benefit to certain situations in a parking garage refurbishment. A lot of experience with Sika over a decade around the world with this Pronto system, and we're able to bring that experience to the Canadian market. We launched the product about 2 years ago into Canada, and we're continuing to build our portfolio of projects as we go here. You've seen kind of this concept earlier in a slide where we've got the buildup of primer, membrane, followed by wear course, followed by top coat. With the Pronto Puma system, we're beefing it up. Everything's a little bit supersized with the system compared to the conventional. So we're thicker primer. We really want to make sure we get that surface lying effect. We're thicker on the membrane with the Puma because it's not as elastic as a pure polyurethane. So we need more mill thickness, more so than we would with polyurethane. And then we take advantage of being able to build a nice wear course by adding some filler into that wear course and then broadcasting sand. So we really bulk it up, and then we finish it off with a UV resistant top coat. So, and then on ramps, we do something very similar. The challenge with ramps is that you cannot do that 83 mil wear course in a single step. So you've got to break it down. So here we show 2 steps. You could do 3 steps as well to build up on a ramp so that it's not sliding down and fluffing down the incline. But essentially same function, both scenarios. We're utilizing the same technology. So we saw earlier 3 to 6 days with conventional coatings. With MMA systems, we're able to go into a matter of hours, single day installation in and out. So that opens up some interesting scenarios. You know, you can install the systems overnight, or you can install them during the day when traffic is low, and you can keep people off and get them back on toward the end of the day. So we have an interesting example of that here, or in the Ottawa area. We worked on a project last year, Michelle and I, and the client had an approach area at the bottom of a ramp. There was really only one way in and one way out, and it was only one lane. But over the years, they developed some cracking. There was some leaking. There had previously been bituminous membrane and probably asphalt on here, but it was leaking, and they needed to address it. But they had a very limited window of opportunity. These folks that park on that upper deck need access on a daily basis. There was no way to split that ramp in half and do half and go back and forth. It was just really not feasible to do whatsoever. But Puma presented an opportunity to get in and out in that very short window and provide them with that solution. The other challenge we had, they'd self-perform some of their work, this particular client, and they wanted us to train a new crew. So we used it as a great opportunity, as a workshop, as a training workshop for ourselves as well as our client. So we began some preparation in the morning. By 10:40, we were pretty much done. And here you see an example of the shot blaster running through to create that CSP 3 to 4 profile. But there was more to it. I mean, we had some concrete repairs that we had done the previous week. And then we also had to do some chipping. There was a real embedment of this old membrane that we had to get out, and it created a lot of divots. So we had kind of a moon surface that we now realized we had to add another layer to our system. So this was a little bit unforeseen, but we now needed to create a leveling layer to deal with the extra surface area and unevenness of this deck. So we began though with priming. So the priming you see here, pretty straightforward, similar to what you saw earlier with the conventional systems. We're using that primer, applying it by squeegee, back rolling, making sure it's getting down, making sure it's evenly spread across the surface. Same goes with MMAs. Nice thing about MMA, 40 minutes later, we're ready to go, right? Very little downtime in terms of time between steps. In terms of an epoxy, that would have been hours before we could have recoated it or started to build up the system on top of it. So next is our leveling layer. This was the layer we had to do to create a fill of the uneven surface. So we took our Puma membrane, the 532, we mixed it with a filler, a fine filler powder, created a slurry, and then we pulled that slurry tight over the surface to essentially drop down and fill into the deeper areas that were going to be problematic. So we use that to essentially level the surface. And this was done less than an hour after the primer went in, and they wrapped it up just before noon that day. Okay, the guys went off to lunch and they came back and we started building up the rest of the system. So here we're applying the membrane itself. This is 64 mils with V-notch squeegee and spike roller back roll to make sure we didn't entrap any air. And we're applying that membrane, taking care to make sure it's uniform, level. We're gridding out and making sure the right volume is going into the right square footage to ensure that we have a uniform thickness of membrane throughout. So this step took place, 64 mils, and then about 40 minutes later, we were ready to start building up our wear layer. So now we're into 2 o'clock in the afternoon, and we're putting our wear layer in. Now the wear layer uses that same Puma membrane material, but we bulk it up with the aggregate or with the filler in order to give it some body, and then we broadcast aggregate into it. So you're seeing here the V-notch squeegee is being used to spread the material. There's again the spike roller to make sure there's no air. And then we have our friends broadcasting into the aggregate, and they're essentially going to carpet that whole area. So there won't be any wet appearance left. It'll be completely carpeted with aggregate, silica quartz in this case. And we see our friend from Merkley, Mike, getting into the feeding the chickens there at the end. Great technique, Mike, by the way. I don't know if you're on this call, but nicely done. So it was a great opportunity to train some people and give some people some exposure to the installation. So once the wear layer is down and the sand is fully carpeting it, we can remove the excess sand. We can sweep, vacuum, blow it off, and essentially reveal a textured surface. And then the last step is to coat that. And we coat that, and we're now in around after 3 o'clock, and we're applying that top coat. And here the top coat is going down by, again, similar methods you've seen before: squeegee and then back roll to make sure the top coat is nicely uniformly dispersed, and that texture is nicely revealed. We wanted a nice coarse texture here. We're at the bottom of a ramp. We also have pedestrians that are going to be crossing back and forth over this section of the deck. We wanted to make sure that this was nicely textured and safe and uniform for people that were going to be using it. So we finished at 3:45. So we started just before 11 with the priming. We finished at 3:45, and we were going to need about an hour for this thing to cure. So at 5 p.m., so we're at about an hour and 15 minutes, that deck was ready to be opened. So about a 6-hour window from start to finish in terms of the installation of the materials. That included that extra step that we had to throw in for the leveling layer. Factor in, we had a rookie crew. First time, I think 1 guy out of 9 put his hand up with experience when I asked at the beginning of the day whether they'd done this type of work. So we were able to get some folks in that had never done it before. Not to say this is an easy system to install, but it's an easy one for contractors that are experienced with conventional coatings to transfer those skills into the installation of the Puma systems. So now they've got a deck that's waterproof, it's durable, it's slip resistant, and it's really ready for action. This job site is, for those in the Ottawa area, it's on the driveway. I think it's number 40, the driveway along the canal. And I think you'll see it now. It's just gone through a winter, so it may be covered in salt and sand, and there may be a dumpster sitting on it, but clean that up, and you're going to see that system is remained intact through the ravages of Ottawa winter. So that's a nice example of a small job that we did here in Ontario. In Europe, they're about 10 years ahead of us with these systems, and they're using them on big areas. Then this is an example of an area we saw a few years ago where we're up into multiple hundreds of thousands of square feet on a 7-story parking garage with the Puma technology utilized throughout. So some good global experience. So the math for Puma, the material itself, it's more expensive certainly than conventional systems, but you offset that with some of the advantages that it brings. It brings the advantages of single day mobilization, minimized disruption of the operation. So there could be, cost savings that could be calculated related to that. And then we start to get into year 2 and 3 and 5 and 6, and we see that we're not coming back to do more costly repairs with a Puma system, whereas conventional systems may be subjected to that in those hot zones. And then, year 10, you may want to refresh the top coat of the Puma system. But all in all, we think the total spend over time for a Puma system can make good sense in selected applications, right? So you need to do the math. If the math works, I like to say, then consider that Puma system for your client. Again, in that example we showed you in Ottawa, where there really wasn't a way through that with conventional materials. Puma was really the only option they had to deal with that scenario they had. So that's it for the traditional park deck systems. I want to introduce you to a couple or one particular technology in particular that can kind of give you a unique solution on ground slabs, and then we'll finish up with some new technology that we have in injection products. So we've talked about intermediate slabs, top slabs, all suspended decks where you've got the concern around reinforcing steel and keeping chlorides out. And then you have the ground slab, the ground bearing slab, slab on grade, slab on ground, different terms for the same thing, right? And the challenge with slab on grade is if there's not an effective moisture barrier below, keeping moisture from rising up you have you're susceptible to the effect of that rising moisture, bringing solubles up and popping off your coating. So if you tried to put a conventional deck membrane coating system, or even a conventional epoxy or polyurethane down on a slab on ground, and you're 2, 3, 4 levels below ground in an underground parking garage, you really do open yourself up to that potential for blistering and failure of the coating because it's impermeable. So the conventional wisdom and what you'll see in S413 is that you need to make sure that your ground slab has some sort of breathable treatment, not an impermeable treatment. What most people do is they will treat the surface with a penetrating silane. Penetrating silane will serve as like a water repellent, so it'll keep water, it'll cause water to bead and not penetrate through the concrete cover. But it will also allow moisture to rise up. So it's breathable while keeping water out on the top side. It will allow moisture to escape from below. So this is a common approach. And the challenge with it, I mean, it's a fine approach and it's served well for many years, but the challenge is you'll have clients that just aren't feeling the aesthetics of that. So yes, it's protecting the concrete. Yes, it's breathable, but you get zero aesthetic benefit, right? So you kind of have this dark, dingy bottom slab of a parking garage, and maybe you've got tenants that want to have more enhanced feel. Maybe you're in a commercial scenario and you want to create user experience, but you can't do it because clear silane doesn't allow you to do it, right? And then if you try to use, again, traditional coatings, they're going to fail. If you try to use breathable paints like acrylic paints, they won't stand up to the traffic. So there's a bit of a dilemma in how do you deal and how do you treat with these ground slab coatings in the market. So at Sika, we've been able to advance one of our technologies to the point where it's a durable coating. It'll protect the slab. It'll give you that nice opaque uniform finish in pretty much any color in the rainbow, but it will also be breathable. So it'll be tough, colored, and breathable. It'll allow moisture at a rate of 3 perms to escape if there's a rising moisture underneath. So somewhat of a unique application or a unique solution to a longstanding application or a longstanding condition. We build that system up with very thin two-step approach. We begin with a primer that's applied very thin. Again, we like primers. And then we do a single coat application of our Sika Elastic 2545, which is a water-based epoxy. It gives us that ability to incorporate a little bit of aggregate to give us some sand texture. We don't use a lot of aggregate because our system's not going down very thin. We don't want our system to be too thick because the thicker you go, the less permeable you become. So we limit the thickness. We allow ourselves to remain semi-permeable. We allow for the customer to have that aesthetic appeal in their ground slab. And here you can just see, by contrast, what the drab side looks like versus the coated side. So if you have a client that's looking for that look and feel, and we're hearing about this almost on a weekly basis once we start to create awareness in the marketplace, that a lot of folks are interested in looking at this option. So something we'd like to share with you today. All right, so that's pretty much it for coatings on traffic deck systems. I haven't been monitoring the Q&A, so hopefully there's been some activity. But now we're going to move into a section of the program where we look at, we're still down below ground, we're still in a parking structure, but we're looking at those leaks that are coming through cracks and joints in the parking structure. And we have some newer technology to help control that we'd like to share with you today. So we're talking about a technology called acrylic or acrylic injection technology. And this is typically incorporated into joints and cracks and certain conditions in below ground structures and waterproofing systems in order to, again, keep water out, be watertight. They're not about being structural, they're about being watertight. And the most common applications we see are in construction joints as well as in cracks. Okay, so we'll focus in on that today. Sika has a slew of different, what we call injection products. Kind of the bottom half of this list is really products that are designed for structural repair. Top part of the list is products that are designed for water tightness to keep, basically to seal cracks and joints and keep walls dry. And we're going to focus in on the acrylic products. The products above are polyurethane products. We're going to talk about the acrylic products today. We're going to zero in on a couple of them. All right, so just the nature of acrylics in general is that they form a nice, tough, elastic gel compared to a polyurethane, which is more of a foam material. An acrylic is very flexible. Imagine Jell-O. So if you look at me in my window here, you can kind of get a sense of the properties of the gel material. Very, very flexible. And that flexibility comes in handy when you're trying to seal out water from a crack. So very, very tough, very elastic. If there's movement in the crack, these products will accommodate movement. They're swellable and hydrophilic, which means if it's dry today when you install it, maybe 6 months from now, you come into a wet season, these materials will swell up in the future. So most what we call hydrophobic polyurethanes, they cure once and that's it. They don't expand anymore in the future. But with these acrylic materials, they're what we call hydrophilic, so they will expand as water becomes present in the future. So they're really effective when it comes to withstanding water under pressure. We reference here a 7-bar hydrostatic head pressure resistance, which equates to 70 meters of hydrostatic head height. So quite substantial. And then viscosity wise, they're very, very thin. They're similar to water. They're actually more like, they're like a milk viscosity, so very thin, which allows it to go where water would go. So very thin, enables it to penetrate into fine cracks. And then another nice aspect of these products is that they're water-based. So we're not transporting chemicals, we're only transporting a concentrate. And then we're adding water at the drop site. So from a sustainable standpoint, you know, the embodied energy of transporting less material, and then also the water cleanup. We're not cleaning our pumps and our equipment and our hands and whatnot. We're not using chemicals to do that. We're using water. So environmentally friendly from that perspective. So there's two main products we focus on here today, which is our 307 on the left, which is a multi-component acrylic system. So we have 3 components that come together on the job site. But what the multiple components allows us to do is a couple of things. We have a feature in that product that imparts passivation of the reinforcing steel. So you're putting water-based material into steel reinforced concrete, perhaps. It's nice to have a corrosion inhibitor built into it. So steel passivation is one of the features that you'll get from the 307. Also variable gel times. We can dial it up from 5-minute gel time all the way to 50-minute gel time, depending on the application. You may or you may not want the material to gel faster. Depends on the stage of water. If you've got running water, or if you want to have that quick cutoff, you can dial it up to gel quickly. Or if you need more time in the pot because it's a longer installation and you don't want the material gelling up in the pump equipment, then you can dial it down to a longer gel time. On the right side, we introduce our 310 material, which is a unique, truly unique acrylic injection material that we've launched in North America this year, making it here in North America. Both of these products are North American made. And we're taking all the complexity of multi-components and measuring on the job site, and we're really simplifying it. We're creating a single component powder that simply all the contractor's doing is adding water. So he's adding water at the job site, or adding the powder to the water, mixing it vigorously for 3 minutes. And then he's got a gel that's going to take about 60 minutes to cure, but very simplified, less packaging involved. So you're not looking at jugs of various other components, and you know, you're basically looking at a bag which can be easily disposed of and very, very sustainable from that perspective. So I have a little bit more on the 310. This really just reconfirms it's very simple to mix. You're adding the powder to the water, and 3 minutes later, you've got an injectable resin that can go into your pump. There's an interesting video here. Hopefully it's smooth enough for you to see, but we basically show kind of a juxtaposition contrast. At the bottom here, we have the older acrylate technology with multiple components. Takes a little bit of time, takes a lot of measurement. And on the top, we're depicting, you know, the very simple application of your water, followed by your powder, and then you're mixing in your powder and you're getting your injection material. So very, very simple. This opens up injection to more people, kind of demystifies it a little bit, helps demystify it by simplifying it. So you're not fully reliant on specialty contractors as much as you were previously. So we can relate this to a parking garage. We can go down into the garage, and we're at lower levels and we're experiencing cracks and leakage. And this section just sort of shows you the basic approach. We kind of take diagonal bore holes. We drill into the wall, attempting to intersect the crack at midpoint of the wall. And we're going both sides because we don't know what direction that crack takes when it goes deep into the wall. We're flushing it out, and then we're inserting port or packers. We're inserting packers that are tightly fit into these holes, and they're going to allow us to inject our resins, be it polyurethanes or, in the case of 310, an acrylate. And we're going to start to pump from low up to high, and as the injection material starts to leak out of the hole above, we can move and continue to work up until we fill the crack. At the end, they go back, they clean up with some patching material, and in theory, you've got now that flexible gel has sealed up that crack and that any voids or fissures in that concrete, and is making that concrete watertight. The example I show here before I wrap up is basically a wet well, and they've got some missing or ineffective water stops in the control joints, and then they've also got some cracks in the wall. And you're going to see here a video showing you the pump under pressure is working its way. I think so you see two horizontal lines where you've got injection ports set up, and he's injecting into the higher one. But you're going to see that the material found its way through the fissures of the wall and then escaped through another crack, which they hadn't prepared for. But now that crack is sealed because this material under pressure can find its way to where water would find its way. And there you see kind of the milk coming out of a crack above that is now sealed with the injection gel. So another opportunity to deal with challenges on a parking structure down below. Another innovation from Sika, utilizing corrosion inhibitors, and in the case of 310, utilizing a simplified packaging and installation to create some simplicity to deal with these challenges in the parking structure. And that's essentially it. That's the full extent of our content today. Again, I don't know if you've been taking advantage of Michelle on the Q&A line. I haven't been monitoring it, but if you didn't get an opportunity to ask a question during our session, please feel free to contact Michelle directly for follow-up, and he can get you set up with information that you need. So you see his email address there on the screen. Make note, and he's also attending the booth during the next few days at the Merkley show, so you can also reach out to Michelle directly at our virtual exhibit. And that's it. Michelle, do you have anything to add at the end?
No,
here?
that's about it for me too. But I'd like everyone for listening your presentation. And like Kamal said, if you have any questions, I'm always available.
Perfect. Well, thank you for attending, and we'll catch up with you afterward, hopefully. Hope to hear from you, and hopefully we can help you with your
Fantastic.
challenges.
Thank you all.